Let's talk about what a radian is. So we know when we have a circle, right? Let me just draw a quick circle. We know that has 360 degrees. But have you ever thought, why is it 360 degrees? Why don't we have like just 100 degrees and then we split that into 4 sections so we would have 25 on each side. So let's say I divided it like this. So I made 4 equal sides. So why is each right angle equal to 90 degrees? Why not just make it 25 degrees? Or if you want to make it a big number, okay, let's say we had 400 degrees. And then if you divided that by 4, then each side or each angle, each right angle would be 100 degrees. So why is it 90? And the thing is, that's just because the way history went. Now the real way to actually get that measurement of an angle is with something called radians. So this is a unit of measurement, right? These are degrees. This is a unit of measurement that we've just adopted. But now a mathematical way of finding that angle is, okay, let's say I have another circle. So we know that this is r, right? That's the radius that's given. And then of course another point here, this is also r, radius. Now what if I told you that I want this length right here, this length, I want that to also be equal to r. And then of course this is just an angle theta, right? So how can I get that length also equal to r? What would that angle have to be for that length equal to r? And we can use degrees again that we already know. So let's do it. So we know that 2 pi r would give the whole circumference, but we only want the fraction from theta, right? So you would multiply by theta and then divide by 360 degrees. And then from there we get r, because that's what we want, right? We want r. So now we're trying to find theta. So we have r on both sides. We can cancel the r's out. That goes out, that goes out. We have 2 here and we have 360 here, so that becomes 1 over 180. So we have pi times theta over 180 is equal to, and the r cancel out, so now it's just 1. So that's equal to 1. Now we can bring the 180 to the other side, so that means that pi times theta is equal to 180 degrees. And then this means that our theta is equal to 180 divided by pi degrees, right? And now if you put this in your calculator, this is approximately 57 degrees. But forget about 57 degrees. The more important thing is that this theta is equal to 1 radian. So now this is the new unit of measurement. So a radian is the angle that you have when you get the radius r as the circumference of the sector that you're interested in. It's very difficult to like define it, but like if you can see from this visual representation, it's easy to see. When you have a radius r and you have another radius r inside the circle, and you want the perimeter of those two, it's called subtending the angle right here. So this r is subtended from this theta, but I don't want to use that word because that was confusing for me. So this, if you're trying to find this r over here, we would just do our usual formula of 2 pi r times theta divided by 360. And then when we do some cancellations, we end up getting that our theta is actually equal to 180 divided by pi, which is approximately 57 degrees, but we don't say 57 degrees anymore, we say 1 radian. Now the thing is, this is very useful because in calculus, so when you do differentiation and integration, so I'll just write calculus, well, we don't use degrees anymore, we use radians. So calculus is done in radians. And of course, like, you can convert from radians back to degrees and degrees back to radians because that is a conversion, right? So let's say I gave you 360 degrees. How many radians is that? Well, that is equal to 2 pi radians, right? Because 180 is equal to 180 degrees is equal to pi times theta, and then 360 would be 2 pi times theta. Well, theta is just equal to 1 radian, so 360 is 2 pi. 180 degrees is just pi radians, of course. And then from here you can go wherever you want to go. So this is pi radians, so I'll just write c for radians, and this is c for radians. That's just how it's written. And you can go on from there and do whatever you need to do. Now, calculus is done in radians, that's important. The other thing is, instead of having this huge formula for perimeter and circumference, we actually have a much simpler formula. And I'm going to derive it so it makes sense. But then the actual formula in the end is very, very simple, I promise you. So I'm going to draw another circle. So I'll draw this circle right here. Okay, and again we have the radius r on both sides. We have r and r, and I'm going to call this angle alpha. Okay, and I want this perimeter here, I want to call it x. I want that length from here all the way to here, I want that length to be x. Okay, So how would we do this? So let's just use our degrees for now. So we would have 2 pi r times alpha divided by 360, and that is equal to x. Okay, we have that. We know that already. Now what do we do? Well, 2 and 360 can cancel out, so we have pi r alpha divided by 180 is equal to x. Okay, so far so good. Now, alpha is just some constant multiplied by theta, right? Because theta is just 1 radian. So alpha is equal to something, let's call it k, times theta, right? Alpha is just like, so k could be between 0 to whatever number you want it to be, right? Because alpha is just a multiple of this angle right here. So this is, if this is 1 radian, let's say this was 1.5 radians, then our k would be 1.5 times 1, and we would have alpha is equal to 1.5. So alpha is just k times theta. So let's write that again. So we would have pi r k theta divided by 180 is equal to x. Okay, so it's not looking very clear so far, so let's continue doing some manipulation. Now we know what theta is. We know theta is 180 divided by pi. So we can get that over here. So we would have pi r k and then 180 divided by pi divided by 180 is equal to x. Okay, now this is looking much better. We can cancel the pi out here and here. Cancel the 180 out here and here. So we would have r times k is equal to x. Okay, we have rk is equal to x, and we have alpha is equal to k times theta. So now let's work with this right here. So if alpha is equal to k times theta, then k is equal to alpha divided by theta. But theta is just 1 radian, right? This is just 1 radian. So that means k is equal to alpha divided by 1 radian. Well, that's just, anything divided by 1 is just itself, right? So that's just alpha radians. And that's it. That means we can put k back in for this right here. So we would have r times alpha is equal to x. And that's our formula for now, the new perimeter, the new formula for the perimeter of a sector. So instead of doing 2 pi r times theta over 360, well, we don't need this anymore. We can just do r times theta, and that's it. That would give you our perimeter. But just remember, theta is now in radians. It's not in degrees anymore, because if it was in degrees, then we'd have to use this whole thing. But now, by using degrees and doing the whole thing, we can now do all this manipulation and end up getting that the perimeter is just r times theta. And now that's the perimeter, so that is p is equal to r theta. And now the formula for the area is very similar, but I'm not going to derive the whole thing. I'll just tell you it's equal to r squared times theta divided by 2. So instead of pi r squared times theta divided by 360, we go from there, and our new formula is now r squared times theta divided by 2. Let's do an example question and it will make more sense. So, the diagram shows a sector OAB of a circle with center O. Angle AOB is theta radians, and OP is equal to AP, which is equal to x. So that means this is a isosceles triangle, so that's theta. So then that means this is 180 minus 2 theta. I'm just getting some numbers down. Okay. We don't know what this length is right here. We know that if you consider this whole thing, so if you consider OB and you consider OA, those are both radii of this big circle right here. So we know that. So we don't know what this length is, and we don't know what this whole thing is. So angle AOB is equal to theta radians, OP is equal to AP is equal to x. Show that the arc length AB is equal to 2x times theta cos theta. So this right here is equal to 2x times theta cos theta. So as soon as we find this radius, let's call it A, then if you do A times theta, then we should end up getting 2x times theta cos theta. So let's try it. How do we get A? Well, we can use the cosine rule, right? So we know A squared is equal to B squared plus C squared. So x squared plus x squared minus 2bc, so x times x squared, cos, and now the theta here is 180 minus 2 pi. Well, now we're 180 minus 2 theta. We're working in radians now, so 180 is actually equal to pi radians. So we have cos pi minus 2 theta. Okay, so far so good. So now we have a squared is equal to, well, x squared plus x squared is 2x squared. So we have 2x squared minus 2x squared. And now cos pi minus 2 theta. So if you remember your trig identities, then cos A minus B is equal to cos A cos B plus sin A sin B. So that is equal to cos pi cos 2 theta plus sin pi sin 2 theta. This is just trig identities. You just need to go and look at those if you forgot. Well, sin pi is the same as sin of 180. Sin of 180 is 0, so this all goes away. Cos pi is the cos of 180, which is negative 1. So this becomes negative cos 2 theta times negative 2x squared. So that becomes positive 2x squared cos 2 theta. So we have a squared is equal to 2x squared plus 2x squared times cosine of 2 theta. Okay, so far still not very helpful. Now I have to use another identity, that is cos 2 theta is equal to 2 cos squared theta minus 1. So how do we do that? Okay, so we have a squared is equal to 2x squared plus 2x squared, and then we have 2 cos squared theta minus 1. Okay, so we have 2x squared plus 2x squared times all of this, and then 2x squared minus 2x squared, right? 2x squared times minus 1, which would be minus 2x squared. So this and then this would cancel out, and you would be left with a squared is equal to 2x squared times 2 cos squared theta, which is 4x squared cos squared theta. You're going to take the square root of that, and then you have a is equal to the square root of all of this is equal to 2x times the cosine of theta. Well, we need to, so now we know what this is. So now a is equal to 2x cos theta. And to find AB, we just do 2x cos theta times theta. That gives us 2x cos theta times theta. Well, you can just rewrite that as 2x theta cos theta. And that's what we needed. That's what we needed to show. So, let me write the line again. So, we're correct over there. So, this radius is 2x times cosine of theta. And when you multiply that by theta right here, which is the new formula for the perimeter of a sector, or at least the arc length of the sector, then we get 2x times theta cos theta. Find the area of the shaded region APB in terms of x and theta. Okay, so this region right here. Well, if we take the area of this whole sector and then subtract the area of the triangle, then we should be good, right? So let's just do that. So the area of the whole sector is equal to r squared times theta divided by 2. Well, we know what r is, right? R is 2x cos theta, so that is 2x cos theta all squared times theta divided by 2. That is equal to 4x squared cos squared theta times theta divided by 2, which is equal to 2x squared times theta cos squared theta. So that's the area of the whole sector right here. Right now we're just working in theta and x. We're not using numbers r and another number for radian right here. So now we have the area of the sector, and now we need to find the area of the triangle. Well, that is just half AB sine C, right? So if we did, this is A and this is B, then our angle would be theta right there. So then we have area triangle is equal to a half AB sine C, which is equal to a half times x times the other side, which is equal to 2x cos theta, 2x cos theta times the sine of theta, which is just the sine of theta. We can simplify that, so we can cancel the 2's out, and we can have x squared. So we have x squared sine theta cos theta. And now all we need to do is need to subtract these two right here. So now we have 2x squared times theta cos squared of theta minus x squared of the sine theta cos theta is equal to the area that we need. Now we can just simplify this further. We only need to have our answer in terms of x and theta. So we could leave it like this, or let's just simplify it. So we have x squared cos theta outside, and then we have 2 theta cos theta minus sine theta. And that is the formula for the area of the shaded region that we need. As soon as you put numbers in for x and theta in radians, x in whatever unit you want, then you'll be able to find the area of the shaded region. So yeah, that's an introduction to radians. I know it's a new concept, but hopefully it's more intuitive, right? Like, why are we always using 360 degrees? Why don't we just use 100 degrees or like 400 degrees or 9,000 degrees? Who's stopping us, right? And that's just history. But once we actually start using mathematical terms and we start thinking, okay, what if I want the arc length to also be equal to the radius, then what's that angle equal to? That angle approximately 57 point something degrees, which we can just call 1 radian. And then from there, it makes other calculations so much more simpler. As we saw, now the new formula for the arc length is just r times theta, and the new formula for the area is just r squared theta divided by 2. So yeah, I hope that makes sense. If it did, please like, share, comment, subscribe, and let me know what else you want to see in future videos.